T-test. This slide contains the procedure T2. T2 stands for the testing procedure number 2. Testing procedure number 1, T1 was described. Z-test was used there, but T-test is used here. What are the conditions for the t-test? We first have to check the assumption, the random sample. The sample must be random. If the sample is not random, we cannot apply the procedure. Normal population or large sample. If the population is normal, there is no need to check the sample size. If the population is not normal, we have to check the sample size, whether it is large or not large. So if we have a small sample size, we should have to check the normality first. As I told you previously, normality can be checked graphically or by test. If you are testing the normality by graph, then histogram, box plot, these are the different techniques, stem and leaf graph, which can be used to check the normality by graph. Or if you want to check the normality by test, the Kolmogorov-Smirnov test and Shapiro test. These two tests in SPSS I used earlier, that can be used for checking the normality. Third assumption is what? Population standard deviation is unknown. This is the one of the significant assumption as compared to the procedure T1. In procedure T1, sigma known. In procedure T2, sigma unknown. So that is the major difference between the T1 and T2. Limit steps are more or less same. Null hypothesis, alternate hypothesis, decide the level of significance alpha. T-test is used in place of Z-test. The one thing is changed. That thing is what? S is used instead of sigma. Because sigma is not known, and according to the theory, sample variance is an unbiased estimator of population variance. So what we can say that expected value of S is a sigma. This is known as unbiased estimate of sigma. Sample standard deviation is an unbiased estimate of sigma, is a point estimate of sigma. In other words, I can write down this as S cap is equal, oh no, I'm sorry. This is equal to sigma cap is equal to S. So if population standard deviation is unknown, one can use S because S is an unbiased estimator of population standard deviation. So t-test and z-test, there's only one thing which is changed, S or sigma. Step number 3, same, either critical region approach you can apply or the p-value approach you can use. Step number 6, you have to take the conclusion. This is one problem that we have to summarize here. Acid rain and the lake acidity. This is the problem. The lake is assumed to be acidic, non-acidic, if pH value is greater than 6. If the pH value of the lake water is greater than 6, the lake is assumed to be non-acidic. If it is less than or equal to 6, the lake is assumed to be acidic. The pH value for mountain lakes in the region, the data is recorded and a sample size of 15 is considered. So these are the 15 values, pH values of 15 lakes. The firstly, what is to be done, because the sample size is small, population standard deviation is not known, we have to check the normality by making normal probability plot. So we can construct this normal probability plot into SPSS to check the normality of the data. And this graph is showing that the points are approximately linear. We can take an assumption of normality. So we can apply the t-test here because population standard deviation is unknown. So what the null hypothesis is, the average pH value is 6, and alternate hypothesis is what? pH value is greater than 6. This is the alternate hypothesis. On the average, the lakes are non-acidic. the lake are acidic. This is null hypothesis, the alternate hypothesis. Now the t statistics is computed. Alpha is 3.05. X bar is computed 6.6, and the mu naught is the value of population mean specified in the null hypothesis. This is 6. And sample standard deviation is computed by this data by the formula S is equal to 1 upon n minus 1 summation x minus mean whole square. X minus mean whole square and a square root of this. This is called sample standard deviation. The sample standard deviation of these 15 figures is to be computed, and the mean of these 15 figures is computed. These two descriptive measures from this data and the normal probability plot. These are the calculation. T statistics is 3.458. This is the observed T statistics. We can use T observed. Now, if we are interested in T observed, if we are interested in critical region approach, so we will use alpha 0.05 and the right tail test will be used because it is greater than. So our critical region will be what? The critical region will be greater than 6. Greater than 6, the arrow is towards right. So this is the critical region. If we are interested in critical region, then this number is to be taken. This number is 0. Taken from the T table 0.05 with the degrees of freedom 14. This number is taken from the T table. Degrees of freedom is what? As I told you previously, degrees of freedom is the denominator of the formula of sample variance. It is n minus 1. If the sample size, this is df. And df is represented by letter nu. I'm just erasing this because df. df is represented by symbol nu. This is not mu, this is nu, N-E-U. Now I am just opening the T table and obtaining this number from T table. Now we need degrees of freedom. Degrees of freedom is 14. So this row is to be considered. And one more thing is 0.05. Again, 0.05, so we have this number, 1.761. So our critical value is 1.761. That number is to be used for comparison. This number is 1.761, not 7 point something, 1.761. 1.761. This number is a critical number. And we will reject our null hypothesis if the calculated value or the observed value of T statistics is above 1.761. And this will be the alternate hypothesis that we have the support. Now the T statistics is computed 3.4. This is 1.7. My number is above this. So null hypothesis is not true. Data do not provide sufficient evidence in favor of H naught. That is why the lakes are non-acidic. The lakes are non-acidic. This is our conclusion. So the 1.761 and this is the calculated value, which is 3.458. 3.458 is in critical region and null hypothesis is not assumed to be true. and alternate. It is supporting the alternate data, supporting the alternate hypothesis. And in alternate hypothesis, what we were saying, that the lakes are non-acidic. This statement is correct. The lakes are non-acidic because observed value of T statistics is more than the critical number 1.761. The same thing can be done by p-value approach. In the p-value approach, we have to look this number, that is 3 point calculate observed value, into the T statistics table against the degrees of freedom 14 and obtain a probability. That probability is known as the p-value. That probability is from the table number 4. I'm showing you this in the table. So what is to be look up? 3.458 or any number which is closer to this against the degrees of freedom 14. I'm showing this into the table. Now the T observed is 3.458 as computed, and degrees of freedom nu is 14 and minus 1. If we look the number at degrees of freedom 14, we have to refer this row. This entire row is referred. In this row, we have to look this number. Instead of looking the 0.05 here, we are looking this number. This is the T score. T score is this. T score is 1.3, 1.7. The closest number that we have in the table is 2.977977. This is the closest number. My number is above this. It means these values are increasing from left to right. So if this number is in the table, will be on the right side of that. So we are assuming this is the p-value. My p-value will be more than this or less than this. It is 0.1, this is 0.05. So whenever I am moving from left to right, these probabilities are decreasing. 0.1, 1%, this is 5%, this is 2.5%, this is 1%, this is 0.5%. My number is not this. My number is the right side of that. So I do not have an accurate value of the p value. I do not have the accurate p value from this table because this number is not exactly matched with any number. But my number, whatever the p value will be, the p value will be smaller than 0.005. Why it is smaller than 0.005? The reason is 3.4 will be on the right side of this. If I am assuming any column to the right side of this point will be smaller than 0.005. So we do not have an exact p-value, but whatever the p-value we have in the problem, it is smaller than 0.005. So that is why I was saying that p-value approach is used in SPSS. The reason is SPSS will give us an accurate p-value. But the table is specific to certain limits, and this can provide us 0.005. Below 0.005, the table is not there. But SPSS will give us the accurate value of this. So my p-value is smaller than this number. You can see p-value is smaller than 0.005. If p-value is less than equal to alpha, p-value is very small, and alpha is in this problem, alpha is 5%. The 5% means 0.005 is much smaller than 0.05. This is alpha, this is p-value. Even I do not have accurate p-value, but I am using the same number which is available, 0.005. So 0.005 still is available, is less than 0.05. So we have to take the decision that data provides sufficient evidence in support of H1. This is conclusion. At 5% level of significance, data provides sufficient evidence to conclude that high mountain lakes in this region are non-acidic. Non-acidic means their pH values are greater than 6. Now I am implementing this problem into SPSS. So I have to take the data because the data in this presentation is in the picture format. I cannot take the data from this presentation to the SPSS. The data should be taken from the book because the book is in the PDF format. So I am moving there and take the data first from PDF file in Excel. Then it is converted into one column. Then the entire one column will be taken into the SPSS and implemented there. This is the book, and I have to search pH level for 15 lakes. This is to be searched into the book. You can see the data, and I'm taking the data from here and put it into the Excel. When we put the data in Excel, it is in the text form. So firstly, we have to convert this text into the columns, and you can see the columns are evenly distributed if I use just finish button, because this preview is giving us a very clear cut concept that the numbers have a fixed length. Each number is based on a 3-digit, one before the decimal, one after the decimal, including the decimal. Each number is a 3-digit number. If your numbers are not equal in length, so you can use delimited, whether it is comma delimited or something other space delimited. Now these are the figures, and these figures are to be taken in one column. So I have to take this and put in the one column. Then these three numbers. Now these numbers are to be pasted into SPSS. This is the SPSS in variable view. I have to define the variable later on. Firstly, I have to place the number here. Very important, these numbers should be in the number format. If these are in string format, you cannot apply the test statistics. Now I am switching to the variable view, and in variable view, I want to change the name of the variable X. And there's a numeric variable. Does it has decimal fractions? Yes. So we have to keep it in the 2 decimal places. As my data is in 1 decimal place, and so you can change the number of places, because all the numbers are of 1 decimal place, so you can change it to the 1 decimal place. It is not required, but you can. One more thing which is very important is measurement scale. All over there, you must have to change an appropriate measurement scale before implementing any statistical procedure. So it is a quantitative variable, the scale is an appropriate way. Now switching to the graph, no, analyze. Very important is analyze. I'm just opening a magnifier so that you can see it in a large font. Very important menu is analyze. All the statistical procedures are found here. In analyze, we have descriptives. I already described this option, and I used explore for checking the normality and for other purposes. So if you have to check the normality, to move first to the explore, and in explore you have to define statistics, descriptive statistics, confidence interval, 95% confidence interval. By default it is used. Now in the plot segment we have stem and leaf and histogram, both normality test with plot. The one thing is normality plot, other thing is normality test. Normality tests are what? Kolmogorov test and Smirnov test. These two tests will be implemented along with the normal probability. So this is one of the very important option that you must have to click before moving next. Now you have to choose the variable. My variable, which is the dependent variable or the quantitative variable, is x. The x is taken here, and that is to be press OK. Just now the output is there. You can see the output. 15 observations we have, no missing number. Descriptive mean is 6.6. This is sample mean. This is confidence interval. As I already told you, this confidence interval, as we were forming in the previous chapter, the confidence interval is what? Mu is from 6.228 up to 6.972, and this is mu cap. This is known as interval estimation. 95% confidence interval is here. This is sample mean. What we have to do, we have to check the normality. It is 0.1. And I was saying you that it should be 0 for a perfect position. It should be 0 for a perfect position, but it is not 0, 0. It is very closer to the 0. So the concept of approximate normally distributed can be used. So if it is 0, 0 mesocortic, 0 stands for the mesocortic in kurtosis, and Skinner 0 means is a bell shaped. So it is very close to the 0. So I can have a perception of this is standard error. What is standard error? Standard error is sigma upon n root. If it is for sampling distribution of mean, sigma upon n root. But in this problem, as sigma is not there, so is a s upon n root. So how standard error is computed? You can see this number by s upon n root. S upon n root, n is 15 and s is this. This is s. So if you divide 0.6719 by sample size, which is 15, then you will get this number. So you can observe 0.6719 divided by 15. The answer will be this. This is standard error. Now we are interested to check the normality. Normality can be checked by histogram or by some other graph. Histogram is supporting my statement of approximately normally distributed. Stem and leaves true. value. This graph is again supporting my statement because only one point is there. And his box plot is in center. The box is in center means we have a perception of normality. Now we are looking the Kolmogorov-Smirnov test output. What is the null hypothesis for Kolmogorov-Smirnov test? The null hypothesis is data is normally distributed. P-value is there. So you can see the p-value here. H naught is data is normally distributed. H naught, it is normal. I'm just putting it as normal. Data is normal or normally distributed. And alternate hypothesis is what? Data is not normal. P-value is there. These are the p-values of, this is the p-value of Kolmogorov-Smirnov test. This is the p-value, the SPSS. Wherever you see the sig value in SPSS, it is p-value. This is p-value of Shapiro test. This is p-value of Kolmogorov test. And our conclusion will be what? If p-value is less than equal to alpha, then reject H naught. So my both p-values are more than alpha, if alpha is assumed as a 5%. So 0.2 is more than 0.05, 0.96 is more than 0.05. So in the both tests are confirming that the data is normally distributed. The normal distribution, the data is normally distributed. Now we have to apply test statistics, which is t-test, for this problem. You have to go to the analyze. In analyze, we have a menu of compare means because we want to compare the pH value with 6 to compare mean with a number. So these are the different options. One sample t-test, that is my test to be implemented here. Independent sample t-test, paired sample t-test. In the next lecture, we will record these two options. One way ANOVA, this is chapter number 13, where the multiple means will be compared. This is very important menu. Here I am going to use this one sample t-test because I have to compare one value, which is 6. Now, this is the option, choose the variable X. In option 95%, my alpha is what? In the problem, my alpha, I think it is 5%, right? So if the alpha is 5%, then we can use. Cancel it. The value by which we are going to compare. We are going to compare by 6, which is stated in the problem. So this number is must be plugged in a one sample t-test. In two sample t-test, it is not required because in two sample t-test, we have to compare whether the two means are same or not same. But here we have to compare the mean with a number. So this value is there. You can see the t statistics is 3 point something. And sample size, this is the descriptive measures. I am placing this output into my presentation, and then I will explain the output and compare this with the already calculated results. You can see the SPSS output here. It's total number of observations, which is the sample size, is n 15. This is sample mean x bar. This is sample standard deviation S, and this is the standard error, S upon n root. Standard error is what? S upon n root. You can substitute if you divide 0.6719 by under root 15, you will get this number. Now this is the degree of freedom, which is n minus 1. The formula is n minus 1. This is the t-score. T-score formula is x bar minus mu sigma s upon n root, not sigma upon n root, s upon n root, which is standard error. So what is x bar? X bar is 6.6. So this t-score you can calculate and confirm the value of the t-score, just 6.6 in SPSS, minus the mean of population, which is stated in the H naught, it is 6, and divided by the s upon n root, and the value of s upon n root is 0.1735. 0.1735 is the value of a standard error. If we divide and solve this quantity will be 3.45. This is equal to 3.45. Now the p-value. This is two-sided p-value. P-value, how the p-value is obtained? Just look up this number into the t-table against the degrees of freedom 14. You will get the one-sided statistics. That one-sided statistics will be doubled. You will have the two-sided statistic. But my question is what? My question, I am testing either two-sided. Two-sided means what? This is two-sided. So you have to change the option of one-sided test in SPSS. In SPSS, we have the more options. You have to, I forgot to put the option of one-sided test. By default, it is two-sided test. That is why this value is here. If I divide, if I want to have one-sided value, then I should have to divide it by 2. This is 0.002. And then 0.002 is to be compared with 5% level of significance. And our decision will be same as we have here. The acidic, the regions are non-acidic because H1 is true. The p-value is very small on two-sided. If I divide it by 2, it is more smaller than this. 0.002. So 0.002 is very, very smaller than 0.05, which is the level of significance, alpha. So our null hypothesis will not be true. And the data provides sufficient evidence in support of H1, and final conclusion is the same as we did previously by using the manual solution. So we have a manual solution of this problem, then we have a SPSS solution of the same problem. And this is the last slide. In this last slide, we have to summarize the procedures for one population mean. If sigma is known or unknown. If sigma is unknown, we may switch to the Z statistics. If sigma is, oh, I'm sorry. If sigma is known, we have to switch to the Z statistics. If sigma is unknown, we may switch to the T statistics. So these are the two paths. So initially you have to check whether sigma is known or unknown. If sigma is known, you may switch to the Z. If sigma is unknown, you may switch to the T. Why I am using the may? Because other conditions are also be checked. If the population is normal, then this is Z. So Z can also be used only whenever we have a normal population or we have a large sample. If population is not normal, but the sample size is large, we have to switch to the Z again. So that is the other condition we have to check. If the sigma is unknown and the population is normal, is the population normal? Yes, the t-test. If the population is not normal, still you have to check the sample size. If the sample size is large, then we have to use this procedure 1. This is T1, testing procedure 1, and this is the testing procedure 2. So these two procedures will be used if the population is normal or the sample size is large. In any of the, if any of the two conditions is fulfilled. If sigma is known, T1 is used. If sigma is unknown, T2 is used. Other tests are what? These are the non-parametric tests. You can apply the non-parametric test in other situation. These non-parametric tests are described in chapter number 15. That is the end of this recording.